Nestled in the Cheshire countryside stands a landmark so vast it can be seen from the Welsh hills nearly 60 miles away. And for 80 years, it's played a crucial part in both science and in world history. It's part of a site that played a leading role in the birth and then the development of a whole new way of looking at, or rather listening to, our universe. But it also played an important role in top-secret military intrigue during a period of terrifying world tension. It's one of my favourite places in the world. This is the magnificent Lovell Telescope at the heart of Jodrell Bank. Welcome to the sky at night. I'm always excited to be here at Jodrell Bank. Every time I visit, that first glimpse of the enormous Lovell Telescope looming over the countryside still thrills me, just as it did when I first came here 25 years ago. Once not much more than fields, the site has been transformed into a world-leading centre for radio astronomy. Traditionally, astronomers have used the familiar optical telescope to collect visible light, the kind of light your eyes are sensitive to, and used it to tell us what objects look like out in the cosmos. Radio telescopes are built to detect radio waves, still light but with a much longer wavelength. Invisible to the eye, this radiation from distant sources can be detected by equipment that, apart from scale, isn't that different from a satellite dish on the side of a house. But it's not Friday night telly they're listening out for. These giant dishes are detecting faint radio waves that have travelled millions of miles across space and which can reveal the secrets of some of the most distant and powerful objects in the universe. And it all started here 80 years ago.
On a winter day in 1945, a physicist with a trailer full of equipment drove into a field nearby. What he wanted to do is observe high-energy particles in the Earth's atmosphere. What he eventually developed put the UK at the forefront of a new kind of astronomy and at the very heart of the space race. The man was physicist Bernard Lovell, who wanted to turn his wartime work with radar to the skies above. He borrowed equipment from the army and took it to a quiet spot used by the University of Manchester's botany department, where he intended to stay for just 2 weeks. Tim O'Brien, one of the directors of this site, can tell me what happened next.
Bernard Lovell first came here in December of 1945. The only people here, there were 2 gardeners who worked in botany and a couple of local farmers. He tried to get this radar kit working, couldn't get it to work. One of the farmers pointed out that the fuel, the diesel, was frozen in the generator. So they helped him get it working, sending these radio pulses up into the sky, and sure enough, the echoes returned. But rather than being from cosmic rays, it turned out they were from meteors, they were from the trails from shooting stars. And it was actually that turned Lovell into an astronomer and made this an observatory.
Through sheer determination and curiosity, Lovell was helping to turn wartime radar equipment into a new scientific tool for astronomy. Where does he take it next?
So he knew nothing about astronomy. So in fact, he got the person called Manning Prentice, who was a solicitor, but a leading light in the amateur astronomical community. And actually they realised that to study more about these radar echoes from meteor trails, they needed something a bit fancier than the radar kit they got from the army.
Yes.
So actually, he returned to the army and he said, can we borrow a searchlight? And it wasn't the light they were after, it was just purely the mount. And so what they did was they put it in the field just over there, and they strapped all these scaffolding poles to it and basically made a whole bunch of aerials on it, and they used it as the base for a radar aerial which they could steer around and study the meteors.
OK. So what did they find with the meteors?
They studied various meteor showers during 1946 from this field, and in the October of 46 there was a massive meteor storm of the Jacobinids, and they got loads of data on that, and they were invited to go down to the Royal Astronomical Society in December of 1946 to talk about the results. And this was very strange, right, because they were coming into this environment that was absolutely not used to looking at signals with dials and things. You would be looking through eyepieces or taking photographs. And Lovell actually said, we went into that meeting as if we were sort of aliens infiltrating some privileged community, but they left as fully fledged astronomers.
So I guess radio astronomy was born.
Radio astronomy was born at that point, yeah.
Having established a new field in radio astronomy, Lovell turned his sights to a new dish. Completed in 1947, the Transit Telescope was made of a fixed mesh, 217 feet across. And it was soon furthering the case for radio astronomy.
So they built this giant ball. It couldn't tip or turn. It just looked straight up. It had a pole in the middle. The radio waves coming from above reflected, gathered at the pole. What they did detect was radio waves from other galaxies. In fact, they were the first to detect radio waves from another galaxy, the Andromeda galaxy, the nearby galaxy.
So we have radio astronomy. You've got this big dish, but it's not steerable. So then what comes next?
The next thing was this ridiculously ambitious idea that they needed something at least as large, but which they could point to any part of the sky. And that's over here.
Over this way, OK. What Lovell was proposing was the largest steerable telescope in the world. A crazy ambition at the time, and one that some said just couldn't be done.
Nobody had ever done anything like this in the world before, and it took him a long time to get an engineer to agree to help design it with him. And he finally found Charles Husband at the end of the 1940s, just early 1950s, and he was prepared to take on the task.
Wow.
I mean, Husband sort of felt he was a bridge builder, so he thought, well, it's the same sort of design as a big suspension bridge or something. And in fact, it looks like it's very Victorian sort of engineering riveted together. They had to build and design specially designed railway track with railway bogies on it that turn it around. Up in the tops of the towers, actually, you've got another bit of army surplus equipment. The whole ball of the telescope tips on gear racks that came from the two 15-inch gun turrets from World War I battleships.
So he's still pilfering stuff from the Army and the Navy.
Yeah, and those battleships had been in World War I, they'd been used in World War II, and they were being broken up at the end of the war. And they thought, well, this is a handy bit of steelwork, we'll take this for our telescope. And it's still there now.
So looking at the construction, it started in 1952. How long did it take?
It took 5 years, but in the summer of 1957, there was no money left to pay the workers on site, so they were on strike. Lovell there were serious questions being asked about the cost overruns. It really looked like the project would fail, and Lovell's phrase was, he turned to one of his colleagues and he said, we need a miracle to save us.
Yes.
And that miracle did actually happen.
Oh, yes.
The miracle was the launch of Sputnik 1, the Soviet satellite, in October of '57.
So how did this dish play a part in that?
Lovell got a phone call from someone in a branch of government that said to him, we'd like you to try and use a radar on that telescope, not to detect the satellite, but the rocket that carried it into space, that was also orbiting. And that rocket was an intercontinental ballistic missile. The fear was that next time it could be a nuclear warhead. Of course, that drew everyone back in. So within less than a week, actually, they got the telescope to point north and see this rocket as it flew over the Lake District. The fact that the telescope tracked that rocket was effectively what saved the day as far as Lovell and as far as the observatory was concerned.
Yeah, so saved by the space race.
Indeed, saved by the space race.
And it was the space race that led to a very secret role Jodrell Bank played during the second half of the 20th century. As Chris has been finding out.
As the 1950s gave way to the 1960s, the Cold War threatened to heat up. As the Soviet Union faced off with the United States, the entire world lived under the shadow of nuclear annihilation. And Jodrell Bank had an unexpected role in their high-stakes competition. The University of Manchester holds previously top-secret files relating to this era, and I'm lucky enough to be getting a look. Danielle George's dual identity gives her a special interest in these documents. Tell us about your connection to these worlds first.
Yes, so I was at Jodrell Bank in the 1990s, became a professor of radio frequency engineering, and I'm currently the Chief Scientific Advisor for National Security for GCHQ. So this is a great story for me, because it feels like it's sort of come all back around to where I started.
Well, you're the perfect person to tell us about this. So I think people maybe know that Jodrell was able to track the rocket that launched Sputnik, but there was much more to this connection than that.
Yes, so Sir Bernard Lovell at the time had this really curious relationship with GCHQ. First thing I want to show you here.
These were classified, so some of them say secret on and things like this.
Yeah, so they've just been declassified quite recently. And this is the first one I'll show you, is this private telephone network to Jodrell Bank.
Oh, okay, so that they could connect.
From GCHQ, so what they called Lab 5. This is actually the card, just to show the telephone card.
Oh, so these are the different connections?
Yeah, so you like literally circuiting through the country, Cheltenham to specific areas.
Okay, but they had this sort of private line connected. This already feels very spy and
it
Cold
does,
War.
yes.
It's great.
Yeah,
Good.
yeah.
Those secure phone lines would have been crucial as Jodrell Bank secretly tracked Soviet movements, including the historic moment in 1966 when they monitored the first ever controlled landing of a spacecraft on the moon's surface.
The next one I want to show you is the Luna 9 mission. This is the Soviet mission. It was a soft landing on the moon with an idea to then take pictures of the lunar surface. So Jodrell Bank knew about Luna 9, they were tracking it, and then all of a sudden the transmission stops and they're like, oh my goodness, maybe we've lost the transmission. And then it starts again. And J.G. Davis at the time says, I think they're transmitting pictures, images. Well, how can we get these images?
Yeah, because they're recording what they're receiving, so they've got it on tape.
They eventually sort of say, who has something like a facsimile machine, precursors to fax machines? So they call up the Daily Express, say, hey, can we borrow one of these sort of fax machines? That then gets shipped out to Jodrell, but then they're able to print these images of the lunar surface. And this was just incredible.
Yeah.
You know, so you can imagine from a scientific perspective, you know, how Lovell and others must have felt seeing these images.
These images were the very first taken from the lunar surface, and unbeknownst to the Soviets, Jodrell Bank had intercepted them. And there's this letter here from, I think, GCHQ about the Luna 9.
This is from Leonard Hooper, who was the director of GCHQ at the time. They actually sent them the intelligence report. So this is quite interesting, this sort of relationship. Going both ways,
right?
So there's a sharing between them.
That's right. And then he says here that, you know, his American colleagues are grateful. So there's this thing of involving the US as well. We've got Jodrell, and so we can give this information.
Exactly, huge asset, yeah, which GCHQ absolutely knew.
As the space race escalated towards humans getting to the moon, Jodrell Bank was listening and caught voices on a mission that was meant to be uncrewed.
Zond 6 was a Soviet mission, again, another lunar space probe to take living organisms to the vicinity of the moon. So this is not landing on the moon, this is just the vicinity.
People.
And it's not people. So this was unpiloted, but it was like a Soyuz capsule.
And we're talking, this is what, 68? We're right at the heart of the space race.
We really are. So Jodrell tracked Zond 6, listening to all of this telemetry data, and then it starts to pick up voice as well. So we have a recording from Sir Bernard Lovell on the Zond 6 transmissions.
How's your Russian?
Not very good.
No. So these voices, they're coming from the spacecraft. You can see that from the telescope, but they're not cosmonauts on board.
They're not, yeah, but they didn't know where they were as well. So this letter actually has
the translation.
The translation, yeah, from GCHQ. They actually say it is actually the role of a ground controller, and the other one is taking a role of a simulated cosmonaut. So it was two people on the ground relaying messages through the spacecraft rather than a recording on the spacecraft.
So they're testing the communication system.
Exactly that.
So how important was this information from Zond 6?
From a scientific perspective, very important, but from an intelligence side, really, really beneficial. So in the thank you letter here from GCHQ, it even says the intelligence value of this material is potentially considerable.
And again, the sense, you know, in our field as well as yours, Jodrell Bank and its skilled people is regarded as a major British asset. And so it's the sense of it's something that Britain offers the West.
Exactly, yes, yeah, it is a huge national asset.
Look, I really like this. We understand that pressures may be put upon you for release to the BBC of these conversations. Sorry. I wonder what they'd have made of us talking about it now. So how long did this sort of collaboration carry on for?
Oh, a very long time. There are still records well into sort of the 60s and 70s and beyond from GCHQ and Jodrell Bank. We have offices here in the Northwest now. Some I could tell you about, sometime I couldn't. Right. But the fact that we are growing in the Northwest and Jodrell is still this amazing, iconic science facility here in the Northwest as well.
So looking through these files, what surprises you most?
I think it's the relationship. Lovell was always very much a friend of the intelligence community, but quite a curious friend in that he was a scientist as well.
Right.
So when you have amazing science coming back from these lunar missions, it's almost like he didn't care if it was Russian or US or whatever. If there's science part of that, he wants to share that with people.
And that cutting-edge science has carried on over the decades at Jodrell Bank, with the upgraded Lovell Telescope at its heart. Overlooking the telescope is the control room, where Maggie is meeting research support scientist Emmanuel Bempong Manful.
So, Emmanuel, the Lovell dish is an amazing telescope, so there must be a lot of competition to get time on it.
Lovell, as I call it, the majestic Lovell, is one of the most sought-after telescopes on the planet. Astronomers from the UK and around the world can apply for time to use our facilities or telescopes. And I can tell you for a fact that Lovell is one of the telescopes that many astronomers love to use because of the sensitivity that it provides.
And it's no wonder it's in high demand when you look at its track record. So what sort of discoveries is Lovell doing?
Lovell is a groundbreaking instrument when it comes to pulsar discoveries. As at the year 2007, all the known pulsars in the world, about 1,700 of them, 3/4 were detected or discovered right here at Jodrell Bank Observatory. And also fast radio burst, which is also something at the forefront of modern astrophysics research, pinpointing or localizing where these fast radio bursts are actually occurring in galaxies and studying their environments in much more detail.
On its own, the Lovell Telescope is an impressive piece of engineering, but it is also part of a network of radio telescopes linked across the UK. With their headquarters at Jodrell Bank, they create one of the most impressive high-resolution radio telescope arrays in the world, known as E-Merlin. E-Merlin, what is it and what's its capabilities?
E-Merlin is the Enhanced Multi-Element Radio Interferometry Link Network.
Okay, that's quite an acronym.
Yeah. So the network consists of 7 telescopes, including the Lovell. We can observe almost everything you can think of in the cosmos, from the smallest scale structures like meteors and asteroids, exoplanets, all the way to the largest scale structures like galaxies and galaxy clusters. So yeah, this is one of the most powerful instruments currently on the planet.
That power is already providing new insights. In 2023, E-Merlin achieved the first ever radio detection of a Type 1a supernova, a class of exploding star crucial for calculating the vast distances of far-flung galaxies. Long observed, the precise trigger for their occurrence has remained uncertain. So Emerlin was able to do a radio detection of this Type 1a supernova. So what did it find?
Astronomers were able to resolve the host supernova explosion, or the star that was hosting this particular explosion. So it was a white dwarf with a companion star, and so they were able to resolve these two components as the progenitor of this supernova explosion, which is really cool.
Yeah, that's amazing.
Yeah.
This is a huge leap forward in our understanding of Type 1a supernova. The observations revealed that these stellar explosions aren't created by a single star exploding, as some had theorized, but more complex models must be at work, with a second star feeding material which fuels the explosion. And it's the incredible power of E. Merlin that has made that possible.
E. Merlin's resolution and the sensitivity is unique in the sense that it allows E. Merlin to be able to resolve structures. By resolving structure, like see fine details of structures that are as far as 250 kilometers away from us. So if you want to look at this in context, then this is almost equivalent to resolving like a £1 coin in London from Manchester.
Wow.
So if someone was in London
holding up a
holding a
£1
£1 coin, you can literally see that £1 coin from Manchester. That's how powerful E. Merlin is.
While radio astronomy listens out for the signals coming from deep space, it's going back to Jodrell Bank's radar roots, where signals are sent out and their reflections recorded, that may give us a new way of studying what's happening just above our heads.
There's currently a global rush to get more and more satellites into orbit. Everything from mobile phone networks, GPS, to weather forecasting, flood monitoring, and even tracking animal migrations relies on them. And keeping track of them all is no easy feat. But today, the Lovell is being repurposed again, and its upgraded capabilities can now focus on modern threats from space. PhD student Phoebe Ryder is using radar to track what's moving above our heads to protect us from possible dangers.
Hi. Oh my goodness, what an incredible view. Is this actually your office?
Yeah, no, it's so amazing to get to sit and work and look at that.
Tell me about your research. What are you actually working on?
So I'm using the telescopes here, including this big one, to do biostatic radar for space situational awareness. Normally radar is monostatic, so the same bit of kit does the transmitting and the receiving. But we're using these as bistatic receivers. So if you don't have to keep switching, you can keep the system temperature a lot lower, so your sensitivity is much better. It's massive, much bigger than any radar transmitter. So the main things we're looking at are geostationary satellites. And so to get detections, you need something very sensitive to be able to do meaningful work.
And this detailed tracking of the satellites, 36,000 kilometers above us, is getting more and more important. Between 2020 and 2025, more satellites were launched than in all previous history combined. And by 2030, up to 100,000 could be orbiting Earth, each with a limited lifespan. As failed satellites join fast-moving debris and natural space dust, Earth's orbit is becoming dangerously crowded, increasing the risk of collision. But Phoebe's precision tracking could reduce that risk.
There was a communication satellite that exploded about a year ago, so we did some detections of some small pieces of debris.
So, I mean, how big a thing are we talking about, and how big are the chunks of debris, do you think?
So it's difficult to know that, and so what we're doing is trying to characterise how big these bits are. The bit that we observed is, we think, about 65 centimetres.
I'm absolutely blown away by the fact that you are, with a radio telescope, observing something that's 65 centimetres across. Do you have some data that you can show me?
Yeah, so this is a little movie showing it moving. The intensity of the colour is the intensity of the reflection of the radar wave that we're getting back.
Yeah.
So you can see it kind of jittering and moving, and that's because it's tumbling and rotating, and that's how we can get a size estimate, is by mapping the period with which it flashes again.
This single blip on a screen could be the early warning crucially needed. One impact could trigger a Kessler syndrome, a chain reaction turning low Earth orbit into a debris field and cutting off access to space for generations to come.
My question is, because it's exploded, is it kind of stable in that geostationary belt, or could its trajectory come inward at some point?
It could definitely come inward. It's not stable at all. We don't know where these things are going. I mean, there's thousands of pieces of debris from this explosion, and this is just one. So it's a lot of work to map all of these and to get an idea of what's up there.
So it's genuinely incredible to see images of something so small. What do you see for the future? What are your hopes for the future of this technology?
So the hopes for the future are to use the sensitivity that we've got with Lovell, but also combine it with observations from the multiple telescopes that are the E-Merlin network. And so by combining observations from all of these telescopes, should be able to build up a better 3D picture of the debris, which will help with avoiding it and making it less of a hazard in space.
While telescopes like the Lovell can give us great insights into the skies above us, there is much to enjoy purely by looking up. Pete's on site to guide us through the coming months.
I still don't know where the eyepiece goes. Luckily, you don't need one of these to be able to view the planets from your own back garden. And over the winter months, the planets have been in great positions for viewing, when the weather allows, of course. Now most are too close to the sun's glare in the morning and evening skies, but there are still a few out to play. Both Venus and Jupiter are currently visible, bright and obvious as twilight darkens. To find them, look towards the west-northwest around 45 minutes to an hour after sunset. If you repeat this over many evenings, you can see a convergence or moving together of the planets as they move around their orbits in relation to us. And from the end of the month, keep a lookout for little Mercury, which makes an appearance closer to the position of the Sun in the evening sky. While the two planets move across the sky in opposite directions, there's also an interesting interplay to look out for involving the Moon over the next month or so. Watching how these celestial objects move with the naked eye gives a great sense of the 3D nature of our solar system, something you don't always pick up when viewing a planet in isolation. 3 dates in particular are great to look out for. On the evening of the 18th of May, a thin 6% lit waxing crescent moon sits near Venus, a popular pairing for astrophotography. Then, on the 19th, the now 13% lit lunar crescent appears between Jupiter and Venus. Finally, on the 20th, the 22% lit waxing crescent moon appears close to Jupiter. Jupiter's movement means it'll soon disappear into the sun's glare until later in the year. On its way, there's a lovely meeting between it and Venus to look forward to. The conjunction is visible from the middle of May through to the second week of June. That's assuming we get clear skies, of course. Not only does this present a beautiful thing to watch, it also presents a great opportunity to take a picture with basic kit like a smartphone, a general photographic camera, or a telescope imaging setup. To find it, continue looking towards the west-northwest around 45 minutes to an hour after sunset. And by tracking it for as many days as possible, you can see them come together until, on the 9th of June, they will reach their closest point, with a minimum separation of 1.6 degrees. This is approximately equivalent to 3 times the apparent diameter of the Moon. As ever, if you do take a picture of this or of any other stargazing targets, please send them in to our Flickr account. You can find details at bbc.co.uk/sky at night. Here are some which were submitted recently.
While Jodrell Bank is a historic site, it's also a monument to decades of scientific effort, a place where discoveries have been made and are still being made today. And it's also a pretty fascinating place to visit. But to me, it's more than all of that. It's a reminder, a very visible reminder, that we can do world-class astronomy here in the UK and live up to the dreams of its founders and builders who thought about exploring the cosmos. Let's hope it can do that for another 80 years. Good night.